Hi everyone. Here I would like to present my research with the title of Performance Analysis on a New Design of Blade Shape for Sylvanus Wind Turbine. This is my outline of my presentation, which is I start with the introduction and then objective and scope of my research, followed by methodology, and then I will discuss my result obtained, and then I will conclude all the finding in my research regarding this topic. So for the introduction, actually, as we know that over 200 years, the main source of energy generation is depending on fossil fuel. And then to overcome this situation, environmentally friendly type of energy known as renewable energy was introduced, mostly be one of the global strategy to be used as an alternative for fossil fuel. The renewable energy that try to come out right now mostly come from the solar, wind energy, wave, marine, and several type of alternative or renewable energy. And among the renewable energy sources, wind energy plays an important role in the future in the global economy and has grown rapidly throughout the world. However, to obtain the best of this energy, there are a lot of complex and lengthy studies that need to be performed to develop the performance of a wind turbine system. A little bit information about the wind turbine. Basically, the wind turbine is a device that converts kinetic energy into mechanical energy to produce electricity. And then there are two types of wind turbine. One is known as horizontal rotation, horizontal axis wind turbine, which is that horizontal rotation work with this wind turbine. And another thing is the vertical axis wind turbine, VAWT, which is that both wind turbine depending on the axis of the rotation the blade. The objective of my study is to analyze the wind effect on the new design blade of the vertical axis wind turbine, and then to determine the efficiency of the tip ratio, power and torque coefficient of the new design of the blade. And then the scope of my research right now is the model is designed according to the existing testing model by experimental work, which is that previously we have data from the experimental work, and then right now we want to do a simulation so we can validate the simulation result and then use the simulation result for further investigation regarding the Sylvanus wind turbine. The simulation that we perform at low wind speed, which is that 6, 8, and 10 meter per second, which is that suitable for the Sylvanus wind turbine. And the working fluid, of course, we use the incompressible flow, and that is the equation we use. And then the simulation will perform by using the ANSYS Fluent software. This is the model that we set up for this experiment or of this simulation, which is that the figures show the geometry of the Sylvanus wind turbine, and then the table show the geometric parameter for the Sylvanus wind turbine that used for this simulation. For the meshing and boundary condition, mostly we have rectangular with dimension of 600 times 600 times 1200 millimeter, and then as the conclusion for this meshing and boundary condition, this is the figure that I use for this simulation, which is that the figure 1 there. This one is the inlet velocity for the boundary condition, the outlet pressure, and then the wall, and then here is the Sylvanus wind turbine inside the box, which is that I mentioned 600, and then 120 1000 per 200 millimeter. And then there is the figure of the meshing, which is the inflation around the blade. You inflate the mesh region around the blade, and then different size of two part, which is that this one is the box, and then this one is the Sovinius wind turbine. So this is the fine mesh for the Sovinius wind turbine, which is that here. And as the result, as we can see from the figure, the result for torque and power coefficient, the data for torque with revolution per minute RPM for of Sovinius wind turbine, and the numerical simulation used to calculate torque and power coefficient for each case of wind turbine. And as we can see that all the TSP ratio will increase with the decrease of torque of the wind turbine. And then the torque coefficient plot. Here we plot the torque and power coefficient of the wind turbine, and as we saw that the percentage of percentage of increase in the coefficient of power up to 20% compared to the classical elliptical Sovinius wind turbine that we obtained from the literature. For the pressure and the velocity, a concave blade that take force from the wind inlet is facing at the high velocity at the returning blade, while the convex part which block area from inlet wind speed facing the reduction of velocity during the rotational condition of the blade. And as we can see here, this is the result for wind speed 6 meter per second, 8 meter per second, and then 10 meter per second. And for the pressure and the velocity, you can see that the blade is facing a rotational condition as a vector is rotated around the blade. Here the velocity vector shows the direction of the movement around the blade and the fluid domain, this one. And then for the pressure and velocity, this is the pressure and velocity contour for the blade at different speed of rotational. And as the conclusion, we can say that the effect of wind turbine speed on the performance of new blade, the results show that the performance of the Sovinius wind turbine based on the new design blade shape has increased power coefficient up to 20% with tip ratio of 0.71 compared to the classical elliptical Sovinius wind turbine. The different wind speed produce a different RPM rotation, hence the increasing of power output of Sovinius wind turbine. Then from this result, basically we can use as a data for the next investigation regarding the Sovinius wind turbine, and hopefully the data from this simulation can be used as part of the idea or data to design the best blade for Sovinius wind turbine. So thank you very much.